Today we're just going to take a few minutes and talk about simplifying fiber thickness and orientation analysis using the Fiber Thickness app. Touch on a couple topics today. Starting off, talk a little bit about the Fiber Thickness app and what it's meant for, the location where you can download it from, an overview of a number of the options and parameters and how to set it up and how to save your settings, a little bit about batch processing, and more importantly is to talk about some fiber analysis tips and follow that up by a live demo and just showing a little image manipulation on how to adjust some of the parameters to analyze your fibers. So starting off, the fiber types that are typically used with the Fiber Thickness app are electrospun fibers. You'll see an example of that today, which is this image down here. Natural fibers, carbon fibers we've used before, hair, things like that, cotton fibers. Again, that type of structure. For types of imaging, if you're getting in SEM images, backscatter, secondary electron, from an optical microscopy standpoint, typically bright field imaging, optical images of fibers. The Fiber Thickness app is not installed with Image Pro. You can download it from the App Center, and this is just a picture of it. And that's downloadable as you go into the Image Pro section of our website, Image Pro version 10. You can go to the App Center from there, and then download it from here, the Fiber Thickness app. Just an example, typical image of the Fiber Thickness app. There's a number of sections in here which we'll do a review of. This is just to show an example of the Fiber Thickness app, and you can see how it's measuring the equidistance of a number of these fibers. And you can tell this is an electrospun example. It's fairly complex. It's very complex. And then you have different data views to do your data analysis of the fibers. So let's talk specifically about the sections. There's really 4 sections in the Fiber Thickness app. One is, and we're going to go through these in more detail, where the measure settings. This is where you're applying calibrations, or if the image is already calibrated, you can just set it to none. You'll use the current calibration. You can set an ROI. You can predefine an ROI that'll be applied to that image or any image in the batch mode. This is very important for obvious reasons in a second. Options. This is where we're picking up and identifying our fibers. And we'll go through this in more detail. But really, it's the type of input of the image, what measurements do you want to make, how are you thresholding it, and there's some options to, depending upon the noise in the image, how much background, how much unevenness that you can set. And finally, there's tools for doing manual editing. Sometimes this is very important, that you may just have. It's just the nature of the nature that you may have to manually define or manually edit some of the fibers. Again, we can classify them and save the image. And finally, the whole batch processing section. So if you have, which we've done before, have a folder of fibers from, say, a particular lot, you can point to that once you have your parameter set up and then do that batch process. So measurement settings. Important thing here, and again, similar to other apps, if your image is already calibrated, you can simply set it to none. It'll use the calibration associated with that image, and that's fairly typical. If the images aren't calibrated and you create a calibration file, you can select it through the drop-down. Preset ROI, perfect example, an image that has a marker bar or a calibration bar. Here this is an SEM with a marker bar on the bottom, but again, with bright field imaging, people sometimes burn in a marker bar, and you really don't want that to be part of the image. So what this allows us to do is to create a region of interest, add it, and it'll be saved in this list so that you can always select it and then apply it to that image. Again, that gets around of measuring an area that's a not valid or invalid section. 2 fundamental types of images. One is, and it's all based upon fiber segments, where you see this branch point or these nodes. This is an area where we don't want to measure in. And so we're measuring and looking out fiber segments, the connections between the nodes, individual fibers, they're sitting there. But what the one is, central point is taking the center point of that fiber segment and taking that measurement, and then doing that for all the fiber segments that you've detected. The second one is a different type of sampling. Similar concept, moving away from the node where there's branches, and you have a parameter set. What is the sampling interval along that fiber segment? You've seen this before in Image Pro, but here you can set it. It's based in pixels. How often do you want to sample across there to generate? Again, depending upon your sample and what the needs are, one or the other is appropriate. So that's setting this up in measurement type, that you're taking measurements along that fiber segment. Minimum length, exactly as it sounds. What's the minimum length of the fiber? Basically, if you have some background, some spots, you'll see an image where we have some of that in a bright field image. There's some background. Basically, this allows you to avoid that and only set up to really measure legitimate fibers. The second thing this setting does, this minimum length, is how far to step away from this node, because you don't want to be measuring in here, going across, taking valid measurements. So this is also saying how far to step away from this node. So it's doing double duty. Input image. What is the type of image you want to work with? And there's two choices here. One is working with a native image, and you'll be setting up and testing all of your parameters on this image. And then you can view from this little viewing button here, see the binarization, because this is what we're using to measure the fibers. So how well can you see that binary image of your measurement options? This is determining and showing you how well you're picking up those fibers. And this will give you a good indication of how successful you're finding them. The second option is, and this is a typical case, sample, just for whatever reason, it's just the nature of the morphology of the fibers, is you just really need to do image processing to do it. Typically how this would be done is it's a combination of, you can use thresholding, but typically use smart segmentation because it's much more robust, which is our machine learning, to find the fibers. You can filter out, non-specific background, maybe partial fibers, broken, whatever it may be. Measurement types and edit range to filter out particles or contamination that are not part of the fibers you want to measure. Find those fibers, count them, and make the binary mask. You're really looking to get a nice, clean binary image that'll then be used in the instance of skeletonization to find and determine the fiber lengths or fiber segments that we can then go ahead and measure. A couple of important points here, and I'll show some adjustment during the live demo, is this group of options here: maximum fiber width, smoothing, and threshold. What this is doing is setting a threshold or setting a limit about the maximum width of that fiber. You have thicker fibers, you want to have a higher value. If you have very thin fibers and maybe they're bending, curling back, not all nice, neat, and straight fibers, this prevents it from over measuring your fibers. So if you have something that's bent back on each other, and the fiber is only 0.5 microns, and you have two fibers that are folded over each other, by setting that limit, you prevent it from measuring basically those crossed over fibers as a single fiber. Depending how noisy your image is, there's a smoothing filter, typically range 3 to 5, but you can adjust this as needed. It's blurring out the background. So this can help with noisy images. One thing you want to make sure of, by setting this too high, you can blur out your fiber. Standard image processing technique. Threshold, we're using edge detection, and this is where you're detecting, after these image processing steps, how well we're finding the fiber. And you can adjust this. If you have very clear, distinct fibers, you can set this to a higher value. There is a default when you, the fiber thickness just has default values, and you can see these are the default values. Actually, dark fibers is on. The important thing here in the flexibility of the fiber thicknesses app is you can either do dark fibers on a bright background or bright fibers on a dark background. So depending upon your imaging modality, this will handle either type of input. Hollow fibers, show a little bit of an example. especially in bright field microscopy. If you have something like think a fishing line, monofilament, something like that, when you pass light through that, what you really see are two edges of that fiber. And depending how you have your setting set, that could actually look like two separate fibers, depending how thick it is. So we have a setting here that if those fibers have that hollow effect, basically we're accounting for that. And that will get over that problem of one fiber looking like two. Correct background, uneven backgrounds, noisy images, really uneven backgrounds more or less, there's an option to correct the background. And then we have some other parameters here about how to collect the data. Data analysis, what's really nice is we can collect the data for all the individual measurements, and we can also get all the statistics. And one of the nice things within the Fiber Thickness App, by default in the statistics, is the orientation. So you're looking to see, again, depending upon the manufacturing process, for example, do the fibers all have the same orientation or mostly the same orientation, or are they just homogeneously spread all over? Again, so this is an important feature within, again, if that's important for the manufacturing process, we'll report out that value. We'll also, the second part of that is the standard deviation of the orientation. So if you have a low standard deviation, the fibers are pretty much directional. Again, as I showed in the earlier slide, we can classify these in typical features within ImagePro, either by orientation or thickness. Manual measurements and manual editing. Sometimes it's just necessary to do. I'll show an image where it's just a classic example. But there's two things that you can do if you need to manually measure, is auto snap for automatic snapping to the edges is included as an option here, and just manually. So just showing quickly what these look like. Typical snap to edge. You can adjust these parameters, of course, if you need to, depending upon your specific sample. But again, finding edge, just manually drawing over, and then just manually going in. Local zoom is automatically turned on. That allows you to go to edge where you manually need to find this. You can also use this, so if you've counted the fibers, you can also go in, edit, and then add some more measurements if you need to, using either tool. Finally, a couple of issues. Here's a couple of examples of fibers that really don't work well for automation. They're too thick. You can see it here. It's broken up. It's massive across. Poor morphology. Things are ill-defined. It's really hard to see, where that fiber is. Multiple layers. Again, just a simple example. You have 1, 2, 3, at least 4 fibers on top of each other. Trying to take automated measurements on that is going to be difficult at best. And you'll probably have a number of errors that you're going to have to go through and correct. It may just be easier many times to do one of the following. Or, I'm sorry, I did miss one. Uneven background, typical SEM image. In some cases, very bright spots, dark spots. The bright background matches the intensity value of the fibers themselves. If you would try to segment or identify this image to get clean fibers, to get that binary image, it's difficult, if not impossible. So what can you do? You really have 3 options. One is, for something like this, you can always come in and make manual measurements, which is built into the Fiber app, which will give you your orientation and the other parameters. If you have places where there are clearly some fibers that are well-defined within the image, you can draw on multiple ROIs and then test just within those areas. And finally, using smart segmentation machine learning, you can use that or image processing to find your fibers. I mentioned earlier there, the slides of the typical protocol for doing smart segmentation, do a count size operation, and get a nice clean background, or a nice clean image where you have gotten rid of all the background, all non-specific materials you don't want to measure, and try to get well-defined fibers. All right. So let's go into a little bit of a live demo here. And all right, I'm going to start with standard settings. This is an app. You load in the app ribbon. So here's my fiber thickness app. As a reminder, there's a PDF attached that you can see all the settings and what each of these features are. Again, you can highlight over each of these and it will give you information about that. This image is calibrated. It's a bright field, and you can see there is a little bit of hollowness in there, and this is what I'm talking about. Something more like a monofilament, but you have those edges really showing up, and depending how you have your settings, when you really want to measure across here, it could almost look like 2. So here are the default settings. Calibration, it's already calibrated, looking down the bottom, so I'm going to set that to none. I don't need to set a preset. I actually have one here for the next image. But again, all this allows me to define an ROI across a section and then save that and apply it so it'll be used over and over again to get rid of marker bars typically. Or if maybe you have some vignetting or along the edges, taking the center field of view. Again, I'm just going to take the central point from here. The minimum length by default, native image. I don't need to go and create a binary image separately with image processing. And here I have my default values again, 50 for the thickness, smoothing filters. I have a bit of smoothing going on, and threshold. Dark fiber is great. I need that. I'm going to correct the background. Data collector. Every time I measure, it'll send the information to data collector. So keep that running data. I can always undo that and clear that out by resetting the table, or I can just, while I'm testing and trying my parameters, maybe I don't want to send it to data collector each time I have to clear it out and only collect it when I really want to. And then I can show data collector. So let's see how the default settings work. I'm measuring fibers, it's doing its image processing. Okay. A couple of things. Some not too bad. When we look in, it's finding too much. And yeah, here's a good example. So let's figure out what's going on. When I click on the preview, you can see that segment, or it's finding beyond the edges of the fiber. A couple things going on. So how can we deal with this? One is there's a bit of smoothing going on, so it's probably blurring the edges a bit. So typically we can lower that a bit. You can preview. Again, changing one image at a time, a little experience. Getting better, still not quite there. But you can see it's certainly tightening up those edges. Secondly, let's try our threshold. Right now, these are fairly well defined. Let's bring this up a little bit. I can type in a number, 10, test it out. And by tightening up that threshold, we're now getting tighter and tighter to finding just that fiber. If I just want to test that, see how we're doing. Again, better. We could probably tweak this a little bit more, a little bit higher threshold. Probably bring down the fiber width a little bit to get that closer. If I collect this now, just for sake of time, the data that's generated will give you the collect number, the name. So if you're doing a batch process, you'll have all the collections, fiber thickness, mean, max, min, orientation, standard deviation of the orientation, and how many fiber segments you've counted. And you also have all the raw data. Again, if you need to do further data analysis, but typically most people are interested in this information here. So let me clear that out for a second. Give one other quick example. I'm just going to reset this. And here, I don't have dark fiber, so that's really going to throw it off. I'll just leave. And clearly, just to do it, I did this purposely about why that ROI is important. You can see I'm now measuring in an area I don't want to measure in. So if you need to recount, it's very simple. Here I've already defined an ROI. It's literally just drawing an ROI across the area you want to and then adding it. I call it marker. I'm just going to recount. And now an ROI is automatically placed and all of my analysis is already taken care of. To show the editing, I can clear the data table anytime. And I can actually edit. So if I needed to do some more editing on this, I can easily do that. A couple of choices. One is, and I'm just going to go into a section here. You have a couple choices. One is under manual edit, I can select a particular fiber, and I can actually move that in and out as needed. Second thing I can do is I can do my edge and finding something that's fairly well defined here. Again, this is a snap edge, so I can come in and manually draw where I need to and automatically snap to edge. The third option is I've clicked the manual measurement line tool. So again, seeing the local zoom on the right, I can always come in or I can set this to a higher zoom, again, whatever is appropriate, and then come in and simply go across and measure. So again, this is an organized workflow. It'll speed up the analysis. When you're happy with that and you have everything set up the way you want to, for automation, you can always save your options. As you can see, I've done that here. Fiber thickness options, so I can save those and then recall those and have everything preset, especially when I'm doing something over and over again. No need to set up over and over again. Batch processing, very straightforward. Load the right settings file. You can pre-test it if you want to. Browse to where your folder of images is located. You'll put the data in a subfolder within the original data, so you're not interspersing. If you save the snapshots, it's not interspersing the snapshots with the real data. It keeps them nice and isolated. And then you have a choice, save snapshots. So if you want to see the results, come back and look at them, save the data, keep results image, run batch. So again, if you have 50 images to go through and you have a process that can be automated, this will save a lot of time versus manually going in and having to manually measure hundreds, if not thousands of fibers.